All right, hello, welcome to Computer Science 30S. This is the Liberty Basic unit in Computer Science 30S, and we're going to have some more fun using Liberty Basic. I'm sure you'll agree. Let's jump right in and have a look at strings. So just a reminder from grade 9, or grade 10, sorry, that a string variables holds strings of characters. They could be numbers, they could be letters, they could be symbols. Again, characters are letters of the alphabet, A, B, C, D, the digits 0 to 9. Other symbols like commas and periods and less than or equals to's and at signs and hashtags and what have you are all considered characters, and strings are simply groups of characters. So you might remember something like this from 20S. Input, please type your name string. Print, it's nice to meet you, your name string. So that was a way that we could use words in our variables. We could store words in our variables by using the $sign denotation at the end of variables. In BASIC, when you want to store a character in a variable, remember that you need to have a $sign at the end. This makes it what we call a string variable. Just a quick note here that a string can have 0 characters. Such string is often called an empty or null string. It's basically nothing. In BASIC, an empty string can be expressed in a string literal as 2 quotation marks without any characters between them. So this is setting name string equal to the null string. It's equal to nothing, similar to making a variable equal to 0. So what kind of things can you do with strings? In grade 10, you basically just sort of took them in, stored them, and printed them out. But just as you can manipulate numbers in a computer programming language by adding, subtracting, multiplying, and dividing, you can also manipulate strings. Okay, and I'm going to show you a few things here. So adding strings is the most common. In Scratch, they use the join command. That's the same thing as what we would call adding or concatenating strings. Here's how you do it. You would say something like input, what is your first name string. Input, what's your last name string. And then you might say full name string is equal to first name string plus a blank plus last name string. So all this line does here is it add the strings together and inserts a blank in between the two names so that you can read the name a little bit better. Call it full name string. You can compare strings with each other just as you like. You can compare numbers. So you can use if statements and check to see if they're equal or not. You can use equal. You can use, this is the symbol for not equal. This is less than, this is greater than, this of course is less than or equal to, and this is greater than or equal to. So if A string equals B string, that means they're equal. This is A string not equal to B string. This is less than, this is greater than, less than or equal to, greater than or equal to. And when you say greater than or equal to, it means that it comes later in alphabetical order. So if A string is greater than B string, then that means that B string actually comes before it in alphabetical order. So you could use that if you're sorting, say, things. When comparing strings, a string is considered to be equal to another string when all the characters in one string are exactly the same in both strings. So they have to be exactly the same. This means that even if they both print the same onto the screen, they can still be unequal if one has an invisible space on the end and the other one doesn't. And I'm not sure if I have an example coming up here or not. Yeah, I do. In the example below, when the line if A string equals B string is performed, the result is to print not the same, since there is a hidden space at the end of B string that you wouldn't see. A string is equal to hello, B string is equal to hello, but you'll notice there's a little space here. You would print both hellos, but you wouldn't see the space because it's a space, and it would say not the same because they are technically not the same string of characters. The space is actually considered to be a character as well, just like in a tweet that you might send. Okay, the string command that you learned. The len function counts the number of characters in a string, so you might need that. For example, Twitter would have to use something like that to check to see if the tweets are greater than 144 characters. The expression inside of the parenthesis must either be a string literal or a string variable. And the result returned is a number and can be used in any mathematical expression. So if it's greater than a certain number. So if you had something like name string is equal to Bob space Jackson, and then you said length name is equal to len name string, it would give you the number 11 because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters long. Other string commands that you should probably learn are left string, mid string, right string, word string, trim string, CHR string, ASC, VAL, upper string, and lowercase string. and I'll just go through them quick here. Uppercase, upper string, and lower string simply convert the string contained in the brackets into the upper or lower case, capitals or not. So for example, if you had name string equal to Bob, and then you went upper string name string, it would be capital Bob that would be printed. The VAL statement, this converts the string inside the brackets into a numerical value if it's a string of digits. If it's not digits, then it returns a 0. So if there are any digits along with characters, it will return the digit. So for example, if I printed 2 times the val of the string 3.14, I would get 6.28. So it takes this 3.14, this string of characters, a 3 and a period and a 1 and a 4, converts it into the numerical value 3.14, and it gives me 6.28. I printed the value of hello, VAL of hello, I get 0 because there's no numbers in here. If I printed the val of 3 blind mice, I would get 3 because it pulls out that number 3. So val is a statement too that you should probably be familiar with. The CHR string and the ASC function are opposite functions that deal with ASCII code. ASCII stands for American Standard Code for Information Interchange. It's a code that was set up many years ago so that allows us to have to know what the letters are numbered, which is it's a way of sort of having a convention of allowing us to know what these strings are. So this allows characters to have a numerical equivalent. This allows computers to represent letters with numbers, which can be converted to binary code, which allows them to talk to each other. ASCII code deals with all 26 letters of the alphabet, upper and lower case, along with the digits 0 to 9 and special characters like exclamation mark and the @ sign and the hashtag sign and so on. Now that the internet has linked computers globally, ASCII has been replaced by another sort of convention. It's called UTF-8, which allows for foreign characters, like all of these things. Okay, ASCII doesn't allow for that, but for the most part, when we're dealing sort of in the English-only language, ASCII code works just fine. So CHR string converts the ASCII number to the equivalent letter or character. So for example, if you printed CHR string of 77, you'd get a capital M. If it was CHR string of 34, you'd get a quotation mark. And if you had a CHR string of 155, you'd get a greater than sign. So CHR string just takes all those numerical values, all those numerical codes, and converts them into the letter. ASC is the opposite. If I have the ASC of a capital A, I get the number 65. If I let name string equal to Tim and then take Tim and try to take an ASC of that, I'm going to get the number 84. Note that if the string is more than one character like Tim, only the value of the first character is returned. So T, capital T and 84 are linked in the ASCII code. And you might want to actually do a Google search on the ASCII code and have a look at that. Okay, so a quick Google search of ASCII table gives you all of these values here. So, for example, ASCII code 80 results in a capital P. ASCII code 112 results in a lowercase p, and so on. And then there's the extended codes here as well for sort of odd characters. So the ASCII table has values from 0 to 255. The letters that you don't need to know this, you can look this up just about any time you want. Capital A to capital Z is 65 to 90, and lowercase a to lowercase z is 97 to 122. If you want to look in the help file or Google it, you'll see all the other character codes. Trim string, it removes any spaces from the start and end of the string and string expression. This can be useful for cleaning up data entry, among other things. Does not remove spaces in the middle of strings. So for example here, if you typed sentence string is equal to space GREE space TINGS space, and then you ran the trim on it and then found the length of it and then you printed it, you would get 10 because you would get GREE is 4, 5, 6, 7, 8, 9. Oh, it should produce, sorry, no, there is a space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you get the number 10 because it's 10 characters long, including the space here, but the space at the start and the space at the end are deleted. So that's what trim does. Word string will return a single word out of a string of words. So for example, if you had the word string of the quick brown fox jumped over the lazy dog with a comma 5, it would produce the 1, 2, 3, 4, 5th letter in the sentence. And there's likely some background coding that's going on there that's looking for spaces. That's how they determine how word strings work. Word string is probably a built-in block, much like you learned in Scratch or BYOB. There is no assignment this lesson, just you should take some time to investigate on your own. You should have a look at the ASCII table. You should have a look at the functions word string, trim string, CHR string, ASC, file, upper string, and lowercase string. Maybe spend a few minutes, see if you can get the computer to print this out. It's kind of challenging to get that quotations in there because, well, as you'll soon figure out, as soon as you put quotations in, then it doesn't print them. And then next lesson, we'll look more at left string, mid string, and right string. All right, have a good day.